Maximum Product Subarray. We will make the output clear first, then see why negative values force us to remember two running products. Before discussing the algorithm, let us be precise about the question. The input is 2, 3 minus 2, 4. A subarray must be contiguous, so its values must occupy one unbroken range. Consider the product of every possible contiguous subarray and return the largest product. For this input, the expected output is 6. The subarray 2, 3 produces 2 times 3, which is 6. We return the product, not the subarray indices and not the sum. Build the array from left to right. The highlighted range shows the winning subarray. Indices 0 through 1 contain 2 and 3. Their product is 6. With positive values, a large running product seems useful, but multiplying by a negative flips the sign. A large positive becomes negative, while a very negative product can become the next large positive. 0 can also restart the subarray because every product crossing 0 becomes 0. At each index, compute 3 candidates for a product ending exactly here. First, start a new subarray using the current value by itself. Second, extend the previous maximum product. Third, extend the previous minimum product. This is the candidate that rescues us when another negative value appears. The minimum is not a bad value to discard. It may be a large negative product waiting for another negative. For example, negative 6 times negative 4 becomes positive 24. So every step preserves both extremes, the largest and smallest product ending at the current index. At index 0, the only subarray ending there is 2. Initialize current max, current min, and best to 2. Using the first value also handles arrays containing only negative numbers. At index 0, the only product ending here is 2, so the only candidate is 2. Choose 2 as the new maximum ending here and 2 as the new minimum ending here. The global best remains 2. At index 1, the current value is 3. Start with the previous maximum 2 and previous minimum 2. The 3 candidates are 3 by itself, 2 times 3, which is 6, and 2 times 3, which is 6. Choose 6 as the new maximum ending here and 3 as the new minimum ending here. Compare the new maximum with the global best. 2 becomes 6. At index 2, the current value is minus 2. Start with the previous maximum 6 and previous minimum 3. The 3 candidates are minus 2 by itself, 6 times minus 2, which is minus 12, and 3 times minus 2, which is minus 6. Choose minus 2 as the new maximum ending here and minus 12 as the new minimum ending here. The global best remains 6. At index 3, the current value is 4. Start with the previous maximum minus 2 and previous minimum minus 12. The 3 candidates are 4 by itself, minus 2 times 4, which is minus 8, and minus 12 times 4, which is minus 48. Choose 4 as the new maximum ending here and minus 48 as the new minimum ending here. The global best remains 6. The scan is complete. The global best is 6. The highlighted subarray 2, 3 produces 6. Later products ending at negative 2 or 4 do not exceed it. Each index performs constant work, giving O of n time and O of 1 extra space. 0 breaks any product crossing it, but the current value candidate lets the algorithm restart naturally. For a single negative value such as negative 2, initialize from the array value so the answer remains negative 2 instead of incorrectly becoming 0. No special branches are required. The same 3-candidate rule handles both cases. Here is a clean interview explanation. At each index, track the largest and smallest product ending exactly there. Use 3 candidates, the current value, previous maximum times the value, and previous minimum times the value. The minimum matters because a negative multiplier can turn it into the next maximum. Update the global best from current max. This gives linear time and constant extra space. The solution sets up the state for this rule. Track both maximum and minimum products. A negative value can swap the role of maximum and minimum. Track both products ending at every index. Keep the largest product seen anywhere. O of n time and O, 1, extra space.